All right. Hey, everyone. Second section, 9.2, alkanes, functional groups, and isomers. You're probably wondering, where is Mr. Worstface? I can't find it. Well, there's a lot of stuff on each one of these slides, so they cover the whole slide. And even though I am a beautiful man, I felt it was more important for you to read words and things like that. So we'll get started. If you got any questions at the end, let me know. I hope this goes smoothly. We'll see. All right, so let's talk about different structural, condensed structural formulas, and even formulas without bonds. So let's look. This is ethanol. Ethanol's got two carbons in it. That's why it's eth. And if you look at it, this is just CH3, CH2OH right there. No crazy. This is the molecular formula right here, C2H6O. If I was to write it out, this is what it would look like. And that's the structural formula. But if we want to condense it down, we can take this part right here, make it just CH3. Take this blue part, make it CH2, and then here's our hydroxyl group coming off with the OH right there. So that's what it could look like as a condensed structural formula. And if we want to take away those bonds, boom, we can write it out just like that. You might have actually seen this in biology. I have no idea when I learned this first stuff. I'm pretty sure it was in my freshman biology class of how to write formulas out like that, but who knows? That was a long time ago. We were riding horses to school. Anyway, okay. So let's keep rolling. Here's another one. This is the molecule glycine. That's an amino acid. And the way that works, we got its molecular formula is C2H5NO2. You'll notice that doesn't really tell us much. You might be able to get the molar mass or something. But if you really want to know how this thing bonds and things like that in organic, you got to draw them out. All right. So here's your NH2 right here coming off, and there it is again. CH2 right there. And then we have a COOH. So these are what we call functional groups, which we're going to get into here in a little bit, which is why we separate them out like the way they look there. So just the difference between a molecular formula, structural formula, condensed structural formula as well. Okay, let's keep rolling. Sometimes long chains of CH2 sections are condensed even further. You might see these in like your fatty acids and things like that, because fatty acids have long chains of these alkyl groups, which are nothing more than carbon and hydrogens. And what you're going to see here is we're just going to take the CH3 at the end, combine all of these CH2s here, and those will be CH2, there'll be 6 of them, and then we have that COOH at the end here at the end. So we've condensed it even further. We're crazy. All right, let's keep rolling. Functional groups. Okay, lots of functional groups that we have here. And I wish you the best of luck. We'll see how it goes. Alkanes are nothing more than carbons that contain only carbon and hydrogen atoms, and they only have single bonds. So if we don't have any double bonds anywhere in the thing, and all we have is carbon and hydrogens, we're called alkanes. All right. Alkenes are ones that have only carbon and hydrogens in them. All right. But they have at least one double bond in them. All right. I'm going to skip up here. Okay. Alkynes. They are the same thing as alkenes and alkanes, except they have a triple bond in them. Watch out. Okay. Alcohols contain the hydroxyl group, or they look like a hydroxide off the end, OH right there. That is the alcohol group. An aromatic group means it's going to have a ring structure, and it's going to alternate double bond, single bond, double bond, single bond, double bond. You learned this back in the last chapter with resonance structures. So this double bond could be here or here. It doesn't matter. Just know that it alternates double single bonds. That's how it's an aromatic compound. And then an ether has an oxygen sandwiched in between two carbons there. So if you see an oxygen sandwiched between two carbons, that's called an ether group. All right. There's more. If you thought that was a lot, there's more. So take your time, memorize those as best you can. See what we got. Oh, 6 more. Okay. If you see a nitrogen bonded to 3 things, it could be hydrogens or something like that, by most likely hydrogens. That's called an amine group. All right. An aldehyde is got a C with a double bonded O, and it's coming with the off to the end. It's like a hydrogen here. Now, I want you to look at something. This C double bonded O is in all of these guys right here. You'll see it right here. So it all depends on what this C double bonded O, which is called a carbonyl group, CARBONYL, carbonyl group. This carbonyl group can be found at different spots in the molecule. All right. So this one's found at the end, or if I flip this around, it would be at the beginning. Big hint for you. A starts at the beginning of the alphabet. This carbonyl group is at the beginning of the molecule. Ooh. Ketone, this carbonyl group is in the middle of the molecule. It doesn't have to be right in the middle, but you've got a carbon on the left side and a carbon on the right side, which means the chain can keep going to the right and can keep going to the left. So it's kind of in the middle. And look what letter's in the middle of the alphabet is the K. All right, so this is a ketone right here. So whenever it's a carbonyl group with 2 carbons on either side of it, a carboxylic acid group or a carboxyl group, if you will, here's the carbonyl group. It's basically connected to a carbon over here or something, and then also a hydroxyl group over here, the OH minus ion right there. And you got carboxylic esters, which is essentially the carbonyl group. And then it's got looks like an ether group right here. So you got C bonded to an O to another C. That's an ester, if you will. And then you got amides, which is your carbonyl group attached to almost like an amine group. It's got an N here with some H's coming off. That's an amine group. So they're amide or amide. I don't know how people pronounce it. But that's what you're looking at for functional groups. A lot of those crazy things. So they just have to memorize those bad boys and see how you do. All right. So look at these guys. Just a quick review right here. You got the carbonyl group, which is just a C double bonded to an O. You got the hydroxyl group, which is the O bonded to the H. Basically, you knew it as a hydroxide. You get the amino group, which is the N bonded to 3 things over there. So whenever you got that, might be like a carbon over here, maybe a hydrogen here. We'll show you that later. And then you got your carboxyl group, of course, which has the carbonyl group, just like this one, but it has a hydroxide coming off of it. So something to keep in mind. And then look, here's that aromatic compound right here. But when it's within another molecule, imagine there's a larger molecule that has this coming off of it. We call it the phenyl group. So you might have seen something like that. Like you ever heard of phenolphthalein or something? Nothing to do with that. But anyway, okay. Let's name the functional groups here, okay? See if you can do it without me. If you want to pause it, have a shot at it. Let's see if we can do it together. Here we go. Go. You can do it on your own. But I'll give you the answers. Here we go. This is nothing more than carbon hydrogens, and all I see is single bonds. That's an alkane, all right? Ooh, same thing here. That's right here, but it's got a double bond here. So that's called an alkene right there. This guy right here is called a hydroxyl group right here, a hydroxyl group. And that's all it is, just a hydroxyl group, okay? This guy right here, look at that. You got an O in the middle of those right there. So that would be an ether group, an ether right there. That's an ether. And then if we go here, look at that. Ooh, a triple bond. That's an alkyne right there, an alkyne. So that's what you're looking at with those functional groups, okay? Here's some more. Let's try some more. This is all about practice, making sure, and I show you is when you see these things. Here's a carbonyl group, but notice it's at the end, or if I flip this around the other way, it's at the beginning. So this carbonyl group having an H over here and being the end or the beginning of a molecule is essentially an aldehyde, okay, an aldehyde. This guy right here, look at this. This is a carbonyl group again, carbonyl group, but it's got that hydroxyl group coming off of it. So this is called a carboxyl group or a carboxylic acid. I call it a carboxyl group up there, okay? This guy, see how there's a carbon on either side of the carbon? There's a carbonyl. There's a carbon on either side, so that is considered a ketone. And then we got this guy, carbonyl group. It's in the middle. It's in the middle. But look, it doesn't have a C here, it has an O. So essentially with this C and an O on either side, that makes that an ester right there. And then look, here's our amine group right here, because it's got a nitrogen, a carbon right there. It's just 2 hydrogens. And then here, carbonyl group connected to one of these guys right there. That's called an amide or amide or amide. I don't know. It's something like that. I know how to spell it. Okay. Common names for alkanes. You got 1 carbon is always a meth. So you got methane. 2 carbons is always ethane. And 3 carbons is which is propane. All right. There's another one. It's called butane. That's if you have 4. But that's no big deal. We can get into that later. Molecules that have the same molecular formula but different structural formulas are called isomers. All right. So let's look at these 2 at the top. Compare them. Notice their molecular formula is C5H12. Both of them have C5H12. But if you look at it, they have different structural formulas. This is not the same structure as this right here. So these 2 are isomers of each other. That's what we're looking at there. So same molecular formula, but different structural formula. Okay. Same thing with this C9H20 right there. That is the same thing. They are the exact same molecule or molecular formula, but they are different molecules because they have different structural formulas. Okay. That's something to keep in mind as well. Okay. All right, let's look at these. Okay, this is you're not going to worry about naming these yet. I'll teach you how to name these here in a little bit. But if you look at this is called 4-methyl octane, and that's because this guy right here, this methyl group, comes off the 4th carbon here. And this guy right here is a 2,5-dimethylheptane, which means there's a 1, 2, there's a methyl, and then there's 5, there's another methyl. But if we were to count up all these things right here, they would have the exact same molecular formula. 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. And the rest are hydrogens. They have the exact same molecular formula, but they have different structural formulas. Okay. Same thing with this guy right here. Look at this. 1, 2 carbons, 1, 2 carbons. 1 oxygen, 1 oxygen. And then you have the rest hydrogens. So these are also have the same molecular formulas of each other. They're different structurally. So those are isomers of each other. All right, ready? Let's look at these two. Are they isomers, same compounds, or different compounds that are not isomers? Let's look at these two. You ready? I'm going to count the carbons. 1, 2, 3, 4 carbons. This one's got 1, 2, 3, 4, 5 carbons. It's got too many carbons. These are different molecules, okay? They are definitely different molecules. They can have different molecular formulas and be isomers of each other. Let's try it on. Here we go. Look at this. 1, 2, 3, 4, 5, 6 carbons. 1, 2, 3, 4, 5, 6 carbons. Hey, look at that. They are definitely the exact same because they have the same number of hydrogens and carbons. They have the same molecular formula. But what I want you to think about is what if I took this guy? You see how this part of the molecule here is coming off of the 2nd carbon on this one, but it looks like it's coming off the 1, 2, 3, 4th carbon on this one. Well, what if I actually took this and flipped it? I reversed it so it's like a mirror, and I started the beginning over here on the right side instead of left side. Wouldn't this guy be coming off of the 2nd carbon as well as this guy? So these are actually the exact same molecule. They're just one's flipped around. Okay, so these are the same molecule. All right, let's look at the last one. I wonder what this is. Let's see. You ready? Here we go. We got 4 carbons on the right, and we got 4 carbons on the left. We got a chlorine coming off, let's say, the 1st carbon from the right, but this chlorine's coming off the 2nd carbon from the left. So these have the exact same molecular formula, but a different structural formula. So these are called structural isomers, or isomers, if you will. Okay? All right. Which two are isomers of number 1? Let's see if we can do this one. Let's see if we got 3 carbons, 1 oxygen, and looks like 6 hydrogen, right? Yeah. So let's look. Let's see. 1, 2, 3. Ooh. See if you can do this one. I'll let you do this one. Try it on your own. Go ahead. And then I'll just show you the answer if you want to pause it and look for yourself. And here you go. All right. So number 5 and number 3 were isomers of number 1. Why is this one not? If you look at it, it's got 1, 2, 3 carbons. That's great, but look how many it's got. It's got so many hydrogens, so much more. It's got 8 instead of 6. This guy right here, this guy has 1, 2, 3, 4, 5, 6 hydrogens, and it has that oxygen there. You're like, oh, is that different? But no, look, it's the exact same actual molecule. If we just flipped it around, these are just mirror images of each other. And then why is this one not the same? Well, let's look at it. It only has 2 carbons. That's crazy. This one has 3. So that's why those are isomers. All right, that's the end of 9.2. I hope you enjoyed, and we will pick up again tomorrow with 9.3. We're going to get into naming these alkanes. It's crazy. Remember, if you have any questions, let me know. Okay? Take care.